Hello, good morning. So today I was going to do some live coding. Specifically, I'm planning to work on STT Hero, which is a new Linux desktop app that I've been working on. And then I may also do some open source gaming later. So we'll see. So STT Hero, um, STT stands for speech to text, and it's essentially just a small app you can run on your desktop that records audio and then converts it to text. And on the back end, it's using OpenAI's Whisper, which they released under an MIT license. And in my experience, this works quite well. So you can record audio, and it will give you a pretty reasonable transcription most of the time. I find it probably better than YouTube captions in a lot of cases, so it's quite good. And then there's just this little desktop app, so you click record. You can also upload an audio file, and then this is all written using PyQt. So it should be pretty, you need Python, but otherwise it should be pretty portable and have good performance and such. So first I'll do a demo. Let me see. So what I really designed this to be useful for is to use with language models. So I've had issues with carpal tunnel, so I'm looking for ways to reduce keystrokes and kind of do more with less typing. And I found these new large language models like ChatGPT, you need to type a lot because all the queries are in natural language. And just as a human, it's a lot easier to speak than it is to type. The words kind of come out easier. I can speak probably 2 or 3 times faster than I can type. And then, of course, there's fewer keystrokes. So essentially, what this does is you click record, and then it's going to record for 15 seconds, and then it's going to do the transcription and put it here. And then I can only have it set up so that once it finishes transcribing, it'll automatically copy the text to your clipboard so that it's very easy to paste into a language model. So I'll pull up, this is the terminal I launched it from. And then here I have Perplexity AI, which is kind of like a off-brand ChatGPT that I like. You don't need to log in, it's nice for streaming. And then I'm going to do the Mistral Medium model. And then I'll test it here. Hello, Mistral. Can you please tell me about the Crimean War? So it's finished recording now, and now it's processing with Whisper. And then when it's finished, the text will pop up here and get copied to my keyboard. So it didn't know Mixtral, but that actually makes sense. So what I'm planning to work on today is to improve the multi-threading. I kind of have some interesting ideas about how to do this. So right now, this just runs on a single thread. You click the record button, records for 15 seconds, and then it'll process it. What I'm looking to do is actually want to run 3 separate processes with text pipes sending JSON messages between them, and then have one process be recording and monitoring the volume, one process controlling the GUI, and then one process recording to process for speech to text. And so that when you detect the volume goes low, the person stops speaking, you can stop automatically, trigger the speech to text to run, and then update the GUI so that the user knows, and the GUI won't freeze because it's not a separate process, and then fill out the text when you're done. So it's not doing that now, but that's the long-term vision. So here we go. Hello. I'd be happy to help you learn about the Crimean War. The Crimean War was a military conflict that took place from 1853 to 1856, primarily on the Crimean Peninsula in modern-day Ukraine. The war was fought between Russia and an alliance of Britain, France, the Ottoman Empire, and Sardinia. The main causes of the war were religious tensions and disputes over territory and influence in the region. Russia has long sought to expand its control over the Black Sea and the Balkans, which were under the control of the Ottoman Empire. The Russian Orthodox Church also claimed guardianship over the Christian holy sites in Jerusalem, which was a source of tension with the Catholic Church and the Ottoman Empire. The war began in October 1853 when Russian troops invaded the Ottoman-controlled Danubian principalities of Moldavia and Wallachia. The Ottomans declared war on Russia, and Britain and France soon joined the conflict on the side of the Ottomans. The war was marked by several major battles, including the Siege of Sevastopol, which lasted for over a year and resulted in heavy casualties on both sides. The Battle of Balaclava, which included the famous Charge of the Light Brigade, was also a significant engagement. The war ended with the signing of the Treaty of Paris in 1856. The treaty required Russia to give up its claim to protect Christians in the Ottoman Empire, and also restricted the size of the Russian Navy in the Black Sea. The treaty also established the neutrality of the Black Sea, which meant that no warships were allowed to enter the sea except for those of the Ottoman Empire and Russia. The Crimean War had significant consequences for Europe and the world. It marked the end of Russia's expansionist policies in the region and weakened its position as a major European power. The war also led to improvements in military medicine and the establishment of modern nursing practices, thanks to the work of Florence Nightingale and others. Additionally, the war helped to spur the modernization of the Ottoman Empire and the development of nationalism in the Balkans. So I've heard Mixtral can hallucinate a lot. This all seems, I don't know much about the Crimean War, but this seems correct to me. I can like spot check a fact or two here to make sure it's not making it up. So it claims the Treaty of Paris of 1856 ended the war. And that looks correct. What does Britannica say? Yeah, looks good. Between Russia on one side and France, Great Britain. Okay, yeah, so this looks correct. I really like this Brave summarizer too. I've been using this a lot recently. So it's essentially the same thing that Perplexity is doing. You do a search query, and then it looks at the top few results, and then summarizes them for you with references. This is often exactly what you want when you just search something. And Google is always good at this. Like they like had a lot of data sources. If you search for like stock price of Microsoft, then the graph would just show up right at the top. Whereas this is like a general way to do it for all sorts of things. So let's see what Brave says. The Treaty of Paris was signed on March 30th, 1856 at the Congress of Paris, ending the Crimean War between Russia and an alliance of the Ottoman Empire, the United Kingdom, the Second French Empire, and the Kingdom of Sardinia. And then you get references here. So I can do 0, military history fandom, 2, Wikipedia. And so I think this also means I find Brave AI almost never hallucinates because it's not really like when you ask ChatGPT a question, it's just like looking in its neural weights for like some fact it knew at some point, and then sometimes it will just make something up. Whereas Brave is really just reading these articles from the web and then summarizing them, so it's a lot less likely to just like wholesale make something up. And then you have these like clickable references, so you can easily check on stuff. So let's keep using SDT here. Can you please tell me about the military technology used during the Crimean War? Certainly. The Crimean War saw the use of a number of new military technologies, as well as the continued use of some older ones. Here are some of the key technologies used during the conflict. Rifled muskets. The rifled musket was a significant improvement over the smoothbore musket that had been used in previous wars. Rifling, or the addition of grooves to the inside of the barrel, allowed for greater accuracy and range. This made it possible for infantry soldiers to engage the enemy from a greater distance, and also made it more difficult for cavalry charges to be effective. Artillery, played a major role in the Crimean War, with both sides using a variety of cannons and howitzers. What is a howitzer? So you do often have to edit these a little bit. A howitzer is a type of artillery piece that is designed to fire projectiles at a high angle of elevation, typically between 40 and 90 degrees. This allows the howitzer to lob shells over obstacles such as hills, walls, or fortifications, and to reach targets that are hidden from direct line of sight. Okay, interesting. I also wanted to ask, I've heard a lot of references to the charge of the Light Brigade during the Crimean War. Could you please tell me some information about that? Certainly. The charge of the Light Brigade was a famous incident that took place during the Battle of Balaclava on October 25, 1854, during the Crimean War. It was a disastrous cavalry charge made by the British light cavalry against Russian artillery positions. The charge was ordered by Lord Raglan, the commander of the British forces, who intended for the light cavalry to prevent the Russians from removing captured guns from a Turkish redoubt. However, due to a misunderstanding of the order, the Light Brigade was instead sent to charge a different artillery battery located at the end of the valley, which was heavily defended by Russian artillery and infantry. The Light Brigade consisted of around 670 men who were armed with lances and sabers. As they charged down the valley, they were met with a hail of artillery and rifle fire from the Russian forces. Despite suffering heavy casualties, the Light Brigade managed to reach the Russian guns and engage in hand-to-hand combat with Russian infantry. However, they were soon forced to retreat, having suffered over 100 killed and 150 wounded. The charge of the Light Brigade is often remembered as a symbol of bravery and heroism, despite the fact that it was a tactical blunder that resulted in unnecessary loss of life. The incident was immortalized in a poem by Alfred Lord Tennyson, which begins with the famous line, half a league, half a league onwards, all in the valley of death, rode the 600. The charge of the Light Brigade has also been the subject of numerous films, books, and other works of art, and remains one of the most famous incidents in British military history. Okay, interesting. So you can see how this is kind of designed to work well with language models. You can just do a pretty quick query, write a few sentences of text using speech-to-text, and then copy it back and forth. So now I'm going to do some work on the actual code. And just a heads up, Speech-to-Text Hero is not going to be open source. So I've lost about $10,000 over the last 4 years running Argos Translate, and I'm currently unemployed, so I don't really have the resources to start another big open source project right now. So Speech-to-Text Hero is going to be totally proprietary. It's a money grab, so I'm hoping to sell this. I may do a suite of Linux desktop apps, so you can pay like $30 one time, something like that, and then you get a bunch of software. I was going to initially target just the Linux desktop, but if that does well, then maybe I'll port to other platforms like Windows and Mac. And it's mostly just written in Python, so it's pretty portable. So, anyways, okay, so start at main. So this procman I made to do some of the process management. So this is the main GUI here. And I actually haven't looked at this code in like a month. Let me make this a picture. Okay. Okay, cool. And okay, I've also got to open the VS Code, and I have GitHub Copilot running. So okay, so I want to work on the. So this view is the main application here. I actually got ChatGPT to write a lot of this for me, but that only goes so far. So I'm going to do some cleanup and do the multiprocessing thing I was talking about. So for the multiprocessing, I created procman, which is short for processing man, or process manager, and I kind of forget what it does, but it manages the processes. So process object has, okay, so the goal here is kind of to create kind of a framework. So Unix processes and passing messages between them is a pretty good way to like isolate code and get concurrency, multi-threading, and such. But they're kind of unwieldy to manage, like how you start them, how you kill them, communicating between them. So the goal is to kind of just create like a Python scaffolding around that. So I can usually just spin up processes and then pass the messages between them, and then clean them up when I'm done. So Procman has a dictionary of process GUIDs to process objects, where these are the process objects. Data directory. So I have this nice code here. So it'll like give you a link to where in the file system you should store all your files for the app. Lock, listen threads. Okay. Okay. Okay, so here's how you create a new process. So you create one process manager, and then you call spawn proc, and then this is a functools.partial. I'm still learning how to use Python types. Tools.partial. Is that right? I think so. Okay. So you pass it a function. It's going to have a local lock for the manager. It's going to create a globally unique identifier. It's going to create the pipe between the two processes, and then it's going to make the fork system call to the operating system. So for those of you who aren't familiar with Unix processes, essentially you have one process, and then you make this system call in Python os.fork. I think in C it's also just fork. And then your process gets duplicated, and you now have two identical processes. The difference is that in the parent process, the os.fork will return the process ID, that's PID, of the child. And in the child process, since it's a duplicate, it also called os.fork, and its return value, it will get 0. So that's why I do process ID equals os.fork, and then if you're in the child branch, you call this partial function that was passed, and then this is the pipe between the two processes, and then once the so after the function is returned, then you send this exit process and close, and then on the parent branch, you create this this process object here, and then you're maintaining this dictionary of processes, and then this. So this is a little confusing. So to understand this, you need to understand the difference between processes and threads. So processes are an OS. The terms can be used loosely, but in this case, a process is kind of an OS level abstraction. So I call os.fork to the Linux operating system, and then it creates two processes. Threading is something that happens within a process. So within one process, you can have multiple threads. And in Python, these won't actually be executed on different CPU cores, but they do let you do things like you can like have one thread that's listening for user input, but you won't lock the entire process waiting for someone to press a key. So you can have kind of multiple things running at once. So I have, in the parent process, I have this process manager object, and then it spins off a child, and then creates a thread in the parent that is going to wait for the child process to exit. So that's what this is doing here. And so this wait for exit is waiting for a child process with PID to exit. And so this is happening, again, on a separate thread in the main process. Process.connection.close. So when a process closes, it does this. So it's going to send some text over the pipe, and then when the parent process receives that text, it's going to close the pipe and then call these child listeners. One of the functions that the process manager gives you is it lets you register exit listeners, so you can just do something when a process completes, and then it deletes the process. So I think I include some of this in the main here. So this is main.py. This is what I run when I run the whole app. I use a bound function here. So view.main is like the main like PyQt GUI application, and then this is to kind of test the multiprocessing. So in the main thread, I create a bound function for the GUI, and I create a bound function for the GUI. I print 10 numbers, and I create this function. I bind a function that'll print 10 numbers, and then I create a function to record audio, and then I only spawn the print one, and then call the main one. So the reason I'm putting these in these functools partial is that they're just kind of easier to work with. So you have a bound function, which means you have the function and its parameters, and you kind of bundle them into one object, and then you can just kind of pass it around. So I'm really only using this bound view main, which is my main GUI, which I'm just running on the main process. And then I'm using my procman to spawn bound print, which is just kind of a demo function to print 10 numbers. So what should happen when I run this is I create the app engine, which will create the process manager object, and then I call run. So I bind up the main application here. I bind up this demo thing that's just going to print 1 through 10, and then I spawn the print thing on a new process. So I now have two processes, one that's going to print 1 through 10, and then one that's going to run my application, and then those should just happen in parallel. So I'll do that here. So what should happen is it should print 1 through 10 simultaneously while the application is running. But you can see that's exactly what's happening here. It's printing 1 through 10, and the application is recording audio. And it'll transcribe in a second. And then there it is. So I think what I want to do next is I want to create a function to monitor the volume on a separate process. So I'm going to delete this. This is just unused. And okay. Either. Okay. So I have two volume monitoring implementations here. I have this one and this one. And ChatGPT actually wrote both of these for me. So I can talk some more about that. So I've been experimenting with a new strategy for using uh, large language models to do coding. So the way I've kind of thought about it is they are kind of a replacement for Stack Overflow. So like when I was programming before large language models, I would just run into some issue and then I put the error into Google and then try to find a Stack Overflow post of someone who had a similar issue and then get an answer that I can like slightly modify to use in my code. And I think the large language models just kind of automate that process. So they're very, like, the large language models kind of know the APIs for a bunch of programs that you don't know. So they just know how, and they've seen a lot of examples of people doing the same similar things over and over again. So they aren't actually that good at programming, but they're good at kind of condensing just like existing known things for you, and they can create like a 100-line prototype of something very easily. So I don't know very much about audio processing, so I was able to just describe in natural language what I wanted, and then it gave me these demos. And they don't really work, but they let you can just run them, and then you kind of create 3 demos, and then you pick the best one and just go from there. And so that's kind of how I got this. I can also show, I did a similar thing. I created a Bitcoin Cash wallet. This is on GitHub, so this is open source. It's GitHub Argos OpenTech BCH desktop wallet. So this was created using a similar strategy using ChatGPT. So if you try to ask ChatGPT to like do a large software project for you, it really can't. Like if I say develop me a Bitcoin Cash wallet, it'll just like give me a list of like, oh, do this, 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 and then even if you like give it those list bulletins back one by one, it still can't like integrate the whole project. What it can do well, like I was saying earlier, is it can just generate 100 lines of code to do some basic task. So this desktop wallet was kind of an experiment with that. So I essentially got it to develop all of the widgets for the app independently. So I said, ChatGPT, can you please create me a PyQt widget to send a transaction in Bitcoin Cash? And then I would copy the documentation that was relevant into that query. And then it would just create me a little widget like this. And then I say, can you create me a widget to view balances? And then it creates me another widget. And so then eventually you can build an app. So I have like 5 widgets here that were each developed independently. And it's actually kind of a lot of code in total, but I only had to do kind of the integration and quality control. And then this actually works pretty well. So that's kind of my strategy of like transitioning from just like grunt writing all of the code to trying to do more of a integration and testing. But it only works for certain things. A lot of things you just still have to do pretty much manually. Okay, so that's why I have 2 volume monitors here. They were, I think, generated separately. And I actually don't remember which one is better. So let's try both of them. So low, low, low. Okay, this looks good. So when I'm talking, it doesn't say low, and I think if I stop, it's going to say volume level low again. Beautiful. So volmon is good. Let's try volumon. Testing, testing, testing. So this one works pretty well too. So that's probably why I saved both of them. So it's just a note that doing it for multiple processes, like I was talking about, is possible. Okay, Windows size, special record audio. Let's just rename this one. Oh, on 2. I've also found using ChatGPT, you often just, I make heavy use of Git because you often want to like paste in some code it gave you and then revert it when it doesn't work. I also do a lot of things like this where I'll just like make multiple versions of it, like have ChatGPT generate multiple versions. I test multiple versions and then like delete 2 of the 3. So okay, record audio. So this is using Python threads. That's good. Okay, so this looks pretty good. I like this. So I think I want to modify this so that instead of, so the functionality is good. Like it says low volume when there's low volume. It says high volume when there's high volume. Or I'll change this. Um, user not speaking. Did that backwards. Okay. Testing, 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 testing. Oh, that's kind of wrong. Speaking. I'm speaking now. Okay, this is perfect. Okay. So I can delete this unused import. So what I want to do here is I want to add a function where you can get change of state updates if the you can get a change of state update if the status changes. So let's add that here. State change listeners. Okay. So okay, that's good. And these should be partial. Okay. And I had to do a nums in Python. Um, all right, let's try using the app itself. Can you please show me an example of using enums in Python? Okay. Um, okay. Um, okay. Um, and then if oh shoot, I'm, okay, perfect. So you should be able to add a listener and then get updated when the values change. So let's try that. So I should be able to just add them at the beginning or whenever. So I'll do mom.add. Cool, perfect. So Speaking, 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 speaking. Testing 1, 2, 3. Testing 1, 2. This is awesome. This is perfect. So the goal is you could click start, and then this will tell you when you're no longer speaking. So let's commit this actually. Okay. So now I want to add this to main, similar to how I used to do this bound print. So let's import okay. So test monitor volume. So we want perfect. And then what do I do? Print here. So on. So perfect. So what this should do is we'll run the app, and then in a separate process it'll be doing the volume monitoring. And there'll be no communication now, but we'll just print when it starts and stops. So the app is not launching, so that's an issue. Well, so this worked before when I was just printing numbers. Oh, I'm running Volmont, not main. That explains it. What is it? So also is like Linux audio. Let's Linux hosted.c. Okay, so something went wrong with like the underlying C code. Oh, interesting. So I thought I tested this before. So I think what's happening is I'm trying to access audio in two different processes at once, the volume monitor process and my main process. I thought I had tested this before, and it had worked to kind of validate this idea, but it isn't now. I do wonder, so I'm trying to actually do 3 audio recordings at once. I'm trying to, or 4, because I'm running OBS too. So I'm recording the input of my mic to OBS. I'm doing the audio output of capture to also to OBS, and then STT Hero in one process is recording audio to transcribe, and then in another process is recording audio to um, to um, 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 to monitor the volume. So some combination of that, it's saying is illegal. So I'll look into this a bit. This might actually not be a great issue to try to solve on a stream, because it's actually harder to do on stream when OBS is running. But let's look into it a little bit. So let's see if. Okay, so I'll get rid of this for now. Can you please help me fix this error? I'm trying to record audio from multiple processes at once in Python, and I'm getting this error on Linux. I'm not exactly sure what the underlying issue is. Okay, so this is what I think too. I'm curious what like the theoretical solution is, or there's the easy workaround. One possible solution is to use different audio devices for each. Oh, interesting. You can specify the device index or name within the input. Oh, device 0. So do I do this? It's cool that ChatGPT wrote all this for me. Like I remember it wrote. I did this like a month ago, but it like wrote one version, and then I asked like, oh, can you add a moving average, which is like conceptually pretty easy, but actually like it takes a while to like think through it and actually write code that works. But then yeah, it just did all of this for me. So the thing I'm looking for though is where does. So I'm using this sound device library, which I hadn't heard of, but ChatGPT just told me to import. So I'm looking for input stream. Okay. Channels to. I wonder. Can I look at the sound device docs? Sound device docs. This library seems great though. I think it's like the default Python one, and it's worked pretty well in my experience. But I know very little about sound. It's kind of a whole. Sound and graphics they each kind of have their own thing that I've never gotten too into beyond just doing the basics. So where's the doc for input stream? Okay, sample rate, it's a device. Record audio, input stream using NumPy. I guess I can just try this. So Mixture was right though. This is a real parameter. Stream device equals Will this fix it? No. All right. Let's see if we can solve this. And if this doesn't work, I think I'm going to do something else. Maybe some gaming, or I don't know, figure something out. Copy the code in. Oh, okay. So this isn't the fix. I see. Oh, this is neat though. All right, I think I'm gonna quit this for now, but I'll run this script it gave me. Support 0. Okay. Oh, it does have a bunch. So I think this is my headset. Oh, so I'd have to. So 7, I was like trying to literally use this one. So I wonder if I can just do 3. Would that work? Test. No. Okay. Okay. So I think I would need to experiment with this a bit more to figure out either like recording in one source and then like branching it out to do the different things I need to do, or I don't know, using some other audio library. I don't really understand how sound works in Linux that well. I know it's kind of been a difficult issue for years. My understanding is that the operating system has some low-level library, which is maybe also is built on top of that. But pretty much everyone uses Pulse Audio, which just kind of makes audio usable for like a normal person. So like I'm doing this audio output capture with Pulse Audio and audio input capture from this mic with Pulse Audio. But I'm going to cut this out and undo this. Okay, and then yeah, I think I'm just going to do some Xonotic or Doom now. Is anyone watching? No one watching right now, but I'll probably like repost the replay. I got like 15, 20 views on my stream yesterday, but it was like most people didn't watch the whole thing, and several of them people watched the replay on Twitch. Okay, so all right, let's do Xonotic for a bit first.
Three, 2, 1, begin.
5 minutes remain.
Triple kill.
Impressive.
Triple kill. Remains. Red flag taken. Hijacked. Resource. Welcome. Flag resistance. Flag taken. First blood. Flag returned. Red source. Flag taken. Flag taken. Flag returned. Red flag dropped. Flag taken. Red flag dropped. Flag returned. Red source. Flag taken. Red flag dropped.
Booster.
Flag returned. Red source.
Revenge.
Flag taken. Flag taken.
Oh, it froze again. I don't really have issues with Xonotic, but it froze and crashed yesterday, so I can maybe about to do that again. It was on this server too, so maybe it's a server issue, not an Xonotic issue. Alright, yeah, so it crashed. I think I'm going to call it here, but thanks for watching.